Good morning. This is a presentation of Computer Communications Network. This is our final project for ECE 547 at IUPUI. So this is a basic layout of our presentation. We're going to start out with the statement of purpose. We're going to talk a little bit about the NS3 network simulation. We're going to talk about the very basics of TCP, HTTP. Um, we're going to talk about our implementation, basically give an outline of the overall process. We're going to talk about a little bit about the topology that we use. We're going to talk about our classes that we used. And then finally, we're going to go over the results. So the purpose of our project was to run a network simulation using the NS3 uh, network simulation. Um, so we started out by creating two servers for clients, and then we have two bridge nodes. So the basic topology can be defined as a dumbbell. Um, what we wanted to do was we wanted to use this network topology to simulate TCP, HTTP protocols. We wanted to basically send a file from the client to the server, and we were going to have the server respond to all the requests that the client nodes made. So, what is the NS3 network simulator? Well, it's basically a discrete event network simulator. It's used primarily for educational purposes and research. It is free and open source. So if you would like to use it, you can go to the NS3 website, learn more about it. Uh, so why would we want to use this network simulator with respect to other simulators that may actually be out there? Well, one, it is open source, so that means we can basically manipulate and change the source file to fit whatever need we may have. And this is very good for research and educational purposes, as stated in it earlier. There are tons of useful APIs for it. So the APIs will do most of the heavy lifting. This simplifies a lot of our a lot of our programs that we would design, a lot of our simulations. So we don't have to basically reinvent the wheel as it was. Um, it can be used for internet or non-internet based systems. So um, it's not limited in scope, and this is what gives it its flexibility. It's flexible because it can be used for multiple purposes, and it is open source. So we can modify it to fit our needs. So this is a very basic outline of what TCP and HTTP, what role they actually play in networking in general, and what they will be used for in our simulation. So you can see by the basic outline that this is the TCP IP architecture. You have the four layers: the application layer, transport layer, network layer, and the link layer, or you can think of it as the network interface layer. Um, for our purposes, the top two layers, the application layer and transport layer, are the main emphasis of this project. Um, as you can see, the TCP is used primarily for the transport layer. Um, it is used primarily for helping in the process of delivering error-free transmission of data or packets. Um, and is used primarily in internet-based applications, along with the HTTP protocol. Um, As you can see that in this diagram, each layer is only allowed to interact with the lower layer and its peer process. Um, a little bit about the HTTP protocol. It's used mainly in the application layer, and it is involved primarily with transferring data from server to browser or server to client. So this is a basic outline of our implementation. I believe the way the project is specified in our assignment was that we were to create six different classes, one for TCP client, one for HTTP client, one for TCP server, one for HTTP server, and probably two different helper classes. Um, we found that if we could combine functionality of both the TCP and HTTP protocols, we could simplify the process and only use three classes. The three classes are, TCP, HTTP client, TCP, HTTP server, and TCP, HTTP helper classes. Um, these classes will be used to define and simulate transactions between server and client. Um, so in our simulation, these classes will be doing most of the heavy lifting. They will have many of the functions that are needed to actually run a simulation properly. Um, as stated earlier, our topology is a um, dumbbell network. The goal was for this project was to create a set of nodes stationed at the east, a set of nodes stationed at the west. We found that the dumbbell topology is perfect for that. It is basically that setup. You have your clients on basically on the west side, and you have your servers out on the east side, and they're connected by the two two nodes that connect both east and west. So you can see this topology is basically shown here. As stated earlier, you have your N0 to N3. These are your client nodes. You have your N4 and 5. They bridge the client and server side of the network, and you have N6 and N7. These are our server nodes. Um, the channels connecting all the servers and clients together is CSMA. All right, so here's a little bit about the implementation of the TCP HTTP server class. As stated earlier, we were thinking about combining the functionality of TCP HTTP protocols. The overall purpose for the server class, as stated by the name, it's designed primarily to simulate and set up your server nodes. It ensures proper configuration. It sets up the socket, the IP version, which I believe for this project was version 4. Does a lot of does It's responsible for packet transfer and packet received from the clients. It sends confirmation information to the client, and it closes based on the client's wishes. Um, I also believe for this implementation, the point of the previous projects were to use uh, UDP, but in this case, we found it was much more simplistic to use the TCP socket class. It had a lot of the functionality that we would like within our server class. So we built upon that to give us the functionality that we would need for the TCP HTTP server class. Um, so this is a brief overview of the implementation of the TCP HTTP client class. And just like its name implies, it's responsible for setting up all the functionality for the client. Client client node does a lot of the a lot of the important things within the simulation itself. So, as it states, this class will help set up the client node. It will record the start and stop time of packet transfer. Um, it will set up the packet size. It will get the number of bytes that we will send to the server. It's also responsible for sending and receiving packets from the server or to the server. And then it terminates the connection with the server. And I stated also with the TCP HTTP server class, it's built in similar regards to using the TCP socket class. Um, so also a very important class is the helper class. It is responsible for helping to add the functionality of TCP HTTP protocols, and it simplifies the whole setup of our simulation with the HTTP packets. If you use NS3 at all, you're going to find out that these helper classes are make make setting up and designing your simulations much more simplistic than it would be just simply building from the ground up. As stated, that's one of the strengths of NS3. It has a lot of APIs, and it keeps in mind um, the users when they design their simulations. Helper functions, helper classes go a long way into making NS3 much more usable than it would have been probably using many of the other simulation tools out there on the market. So a bit about the implementation. Um, the helper class it uses several functions to set up the applications for the nodes. So that would include both TCP HTTP client and TCP HTTP server. These functions would be like install, set attributes, and set fields. So install helps to basically install the node to the network. Set attributes, basically it sets any of the attributes necessary for the network to function properly. And set field, which would be used to set all the attributes of the transfer process, I believe. Um, each of these functions are not necessarily defined to just one parameter type. We designed several functions to have different parameter types, and each of these functions can have varying parameter lengths. So now we're going to talk a little bit about the results of our simulation. Did it all work, or you know, or are we just doing a presentation that didn't really work out at the end? Well, our simulation created, I think we did up to 10 PCAP files. Each PCAP file um, has all the information on the transaction between the server and client nodes. Um, the PCAP file contains within it the time, the source destination address, the protocols that will be used, and the length of the packet. Um, for for these PCAP files, we used software called Wireshark, which you can download from Wireshark's website. It's pretty easy to install. You just hit the executable and it should run. Um, for the simulation, we also generated an output onto the terminal, will help us to to see all the processes that are taking place between the server and client. Okay, so here you can see a bit about the results. Um, this is the the outcome of the simulation of our simulator. Um, you can see that starts out by creating nodes, it creates the stack, creates the channel. It does all the basic setup for your network. Runs through, um, it defines the data size, it goes through, does the set fill. One of the functionalities of the HTTP protocol is the use of get, and this is the file that we wish to transfer. Some of the attributes of this file, what language this file would be using. Then you go through and it shows the simulation that's been ran. And it's the start application. You get the start time, and this process basically repeats. Then we have this the simulation will send the packet. You have schedule. You have basically a schedule being kept, and then from here you can see the packet received was 536 bytes, and this is the IP address that it was sent from. Um, and this process just basically continues until the uh, the simulation is done running. And this is a basic outline of our PCAP file. This basically shows, as I stated earlier, the time, source, destination, the protocol. The main protocols being TCP and HTTP. There are some ARPs. Um, and then you can see from line 11 that we have our get function in the file transfer.
Okay, thank you, Tim, for your presentation. That is our final presentation from the our Delta
Group,
yeah,
yes.
from Delta Group, from the ECE 547 communication network taught by Professor Kim. And for the contribution part, Wennan Chang and I and the most of the coding, and Tim in charge of the presentation, and Timothy Johnson in charge of the presentation, and the Jin Jinping Chen in charge of the final report part. We would very like to thank. We would very like you to thank Mohammed and Hassan and Jeremy and Joshua, Luke, Nathan, Sammy, Gregory. It was very fun to work with you and study the same classes with you. It was a fun ride, and we would like special thanks to Hassan and the beta group and alpha group for all the help we can get, because our team is really very struggle as the coding part. So and especially thanks to Professor Kim. If you're watching this, we were very grateful you give us this. We have been a very wonderful semester. Everyone enjoyed it, and hope you can enjoy our presentation. And many thanks.